Okay, what we're looking at here is a differential thermostat. You can see the actual temperature. This is the temperature in the collector right now. Well, actually, it's the probe that would go to the collector is monitoring that temperature. But basically, this would be the collector temperature, and this would be the tank temperature. So when the difference between these temperatures is substantial, this should turn the pump on. This other meter is monitoring the voltage supply, and we'll talk about how this has an effect on it later. But first I just want to show you how uh, the pump can turn on when there's enough heat in the collector to turn the pump on. Okay, so right now I'm just going to try to generate a little more heat. I think the pump should go on when it's about 70, 71, 72 degrees. Now I should be able to get the probe up to at least that temperature. Gotta think hot thoughts here. Okay, we're up to 71 degrees. Alright, at about 72 degrees, the pump turns on. Pretty noisy pump, huh? Well, it's early in the morning. Everything is a little noisy this time. Okay, that's calming down. Okay, so as long as the temperature is above 72 degrees here, and the temperature in the tank is low enough, the pump will stay on. Okay, so I'm going to release the probe now, and we'll let the temperature cool down, and we'll see how long it takes to turn the pump off. Now, we don't want the pump to go off right away, even though the temperature is going down. If that happened, the pump would be going on and off all the time, and it would wear out the pump. Every time this pump starts, it's a bit of a shock. Okay, so now the temperature in the collector is 67 degrees. Remember, the temperature in the tank was 64. So as this gets close to that temperature, it should eventually turn the pump off. Let's see how. Okay, so at 65 degrees, the pump shuts off. Good, everything is working as it should. Now, the next thing I want to show you has to do with the effect of voltage on the pump. If the voltage gets lower, the pump is going to turn slower. Alright, so at 78 degrees for the collector, the pump comes on. And it'll stay on as long as the temperature difference between the collector and the tank is high enough. Now, right now, we'll take a look at the temperature in the tank. You know, the temperature in the tank is 62, almost 63 degrees. So that's a difference in temperature of about 17 degrees. Okay, so the pump is on, but now let's say that the pump is on too long, and the voltage that drives the pump begins to drop because the photovoltaic panel does not have enough current to drive the pump. And that's a situation that we really don't want to happen. Okay, let's just assume that the voltage to the pump is dropping. This means that the battery voltage is dropping too. And if the battery voltage drops too low, it could destroy the battery. So we also have a battery protect circuit. You notice how I've been turning down the voltage across the power source. Now it's like 10.8. Okay, at 10 volts, the pump shuts down. This is the battery protect circuit. Now I'm going to turn the voltage on the pump back up. Let's say the sun just came out from behind the clouds and it's starting to raise the voltage. Now we want it to raise the voltage in the battery much higher than 10 volts because it has to charge the battery also to some extent. So right now that voltage is set at about 13.5 volts. So when the battery voltage gets up to 13.5 volts, it should be able to turn the pump back on, and it does. Okay. So this is just an additional circuit built into this differential thermostat. It's not absolutely necessary, but if you do have a battery hooked in parallel with your photovoltaic panel, it makes a nice option. Okay, that's basically all I wanted to say. Now we'll turn it on. Thank you for your time. This is a DC differential thermostat. It's designed to operate between 10 volts DC and 16 volts DC. Now there are a few controls I just wanted to show you. This switch here is used to view the temperature in the tank and the temperature in the collector. It's a toggle switch, so we can switch it back and forth to look at the two most important temperatures that we're concerned with, the temperature in the collector and the temperature in the tank. These potentiometers, this potentiometer here is the most important one. This one controls the differential. The differential is the difference in temperature between the collector and the tank. And we can actually control that setting with this one potentiometer right here. This potentiometer is used to protect the battery in case the voltage gets too low. If the voltage gets too low, suppose there's not enough sunlight to charge the battery, we'd like the pump to shut off. Otherwise it might drain the battery and damage the battery. Also, it's not good to have the pump running at a very low speed and not at a speed that's insufficient to pump the water up to our trickle-down collectors. Okay, so these are some of the basic features. You see over here, this is the relay. This is what actually conveys the voltage to the pump, and these are some of the controls that determine when the pump should go on and off. Okay, I just wanted to show you that. We'll take a look at the operational system in just a minute.